Start. Yeah, actually, today we are going to see about the code generation through embedded coder. Ashif, ashelif, and ashendif. Here I have some things for you. What about conditional inclusions? Actually, most of the time we use it to generate codes through embedded coder and AutoSAR coder. Here today we are going to generate hash if, hash else if, hash end if, those conditional inclusion in the Matlab through Matlab actually. Right now I am starting with a new command window. We will create a new model in Simulink. Here this conditional inclusion is possible through variant subsystem. We have heard of many types of subsystem. Here we are going to use variant subsystem actually. Let us take a simple variant subsystem. For this we will have some inputs and outputs. Okay, let us have a input and outputs, one output port. Okay, let I am connecting one input port and one output port for the variant subsystem. We need some case, right, to create this variant condition. What sort of variant condition? So for that I have taken a mosquito bat actually for the concept. Here we have some two variants actually. Here it doesn't consist of any of the embedded devices. It is just a basic electronic circuit. But here we let us take some two conditions. One is mode without light and another mode is with a blue light. Actually we have two modes. Okay, let us create two mode execution. Okay, two mode of execution. It doesn't consist of any of the embedded devices internally. Okay, but let us try to generate a code with two types of execution. Okay, yeah, here I am going to show you. There is two subsystems actually. So for the input, let us take the input as switch in, whatever we are using, right? Switch in. And for the output is the the bat is getting short circuited, right? So let us take it as bat out. So now we got one input and one output. For the switch we are pressing in and the bat output we are taking in. Just going with a simple example. Okay, inside the subsystem we have two variants. Okay, first variant is without the blue LED. Second variant is with blue LED. So for the first blue LED, I am just connecting the one and both the inputs directly. So it will work without the blue LED lighting. Okay, yeah. The second subsystem that I am taking directly, the thing is directly when the switch is pressed, the bat will get output. In the second case, let I am adding one unit delay as a concept, so that the blue LED will become an output. Okay, yeah. So I am adding another output for the system. So now the system which has two outputs, one is the bat out and another one is this blue LED. So we need to add two outputs that I am adding. For the first system there is no output, right? So for this variant also we need to add with the second output, which need to be terminated or a ground. Okay, some zero value need to be went to the blue LED. Yeah, let him connecting. Okay, now just we will add another output for the system, which is blue LED. Let I am naming it here. How this and this conditional inclusion is matched, you can ask. We are going to present a two software for this for this mosquito bat company, let us think. Okay, yeah, which needs to be conditionally compiled for two conditions. One condition is without glowing of the blue LED, and another condition is the same mosquito company need to sell the mosquito bat for least cost without glowing the blue LED, one with the blue LED, so that in their procurement they can remove the blue LED bulb in the hardware side, so that they can reduce the complexity of the system. But right in software they are asking from us that they need both the variant in a single code. Okay, yeah. For that these conditional inclusions are useful. These are much more used in this SDV concept, which we are going on in hashtag software defined vehicle actually. So I am just giving a conditional inclusion how to generate through embedded coder through this video. Okay, yeah, I'm giving you a rough example. Through this we can generate a n number of codes through this conditional inclusion statements, which means hash if, hash elif, hash endif, and we can add n number of macros with hash defines in the embedded coder through the embedded coder. Okay, here actually we created the system. Here there is a problem, which means we created the system with the two variants, but the customer, which means the mosquito company, the vendor actually for us, need to give the variant before feeding the software. If he is building a software operated mosquito bat, okay, so before he is building and dumping the code in both the variants, you need to build the code. Before building, you need to give some variant conditions, right? How we will give the variant condition means in the command window we have a syntax called a simulink.variant, so that we can create a variance. For first variant I am creating it as normal. Normal is equal to, we know that simulink dot signal, simulink dot parameters, those things. Instead of that we are now creating a simulink variant. Okay, yeah. Now normal is a simulink variant has been created in the workspace. Now another format is blue LED, so I am creating another variant called blue LED. Just I am creating a basic algorithm, not much more. I have been focusing on the algorithm. Just I am focusing on the code generation part, so that algorithm can be modified for the respective problems and solutions. Now blue LED, another variant is created. Okay, right now in the normal we need to give some condition. It is asking, like, for example, a is equal to 1. So in blue LED, LED needs to be 0, so I am giving another one macro. LED needs to be equal to 0. Okay, so that the from our client side you can give that LED just 0 means he will build the very less cost mosquito bat. If he is giving LED is equal to 1 means he can build the higher variant, so that it is easy, right? So LED equal to 1. Okay, right now we have given both things, but in the workspace we can see that LED is not presented over here. So I am assigning initially before building the code, customer needs that some default type, right? So he is giving a LED equal to 0. So LED also came into the workspace. So now you can see just we am saving mosquito, bat, rat, hit, anything we can give, right? That I'm naming it as hit. Just okay. I think so far there is no software enabled mosquito bats on there. Let us hope for the best. And I am doing some basic configuration settings like fill, fixed step, discrete time solver with no continuous states. That I'm giving some sample time 1 millisecond, sorry, 100 milliseconds, no problem. Okay, let me save it. Let us build this code with the embedded coder. Before building with the embedded coder, we need to configure for ERT, so I'm clicking it here. Actually, we need to ask, you have mentioned the variant conditions in the workspace, but where you are used in this subsystem. Here in the variant subsystem, while you are clicking the variant subsystem, we have a tab presented over in the above. It consists of block parameters and variant manager. You just click the block parameters. Right now for the variant activation time we need for code compilation, so I am clicking code compilation. For the subsystem one, it's need to be with the format called normal, so it is normal, right? The condition is normal. And for the subsystem one, the condition is blue LED. I think that what we mentioned in so you can see whenever I am mentioning the variant control expression, the condition is automatically getting read by the thing. So I am just clicking apply and okay. Now let us save and let us generate the code with the embedded code. Before building, let us just generate the code, so that whether it is building without, I forget it. It's a continuous thing I am doing. Whenever we are using a variant subsystem, we need to make it as an atomic subsystem so that it should be independent of the timing things presented over the system. I think we have used a ground block, right? Instead of that, let us try the block with 0. Okay, wherever we use the terminate and ground blocks, most of the time the code won't generate, I think so. Let us try it now. I hope so. That is the mistake that I did. Yeah, correct. I guessed it. Whenever we are terminating a signal or whenever we are starting a signal with the ground one, it will not be generated in the code part. So now what happened means, as in Matlab command window, we have given LED equal to 1 or LED equal to 0. It is not the problem, but it will generate with #if #lf. Now you can see, right, #if it is normal, then LED output will be 0, then the blue LED won't glow, and #lf means blue LED will be glowing with the switch inputs whatever it is receiving. Okay, yeah, actually I want to show you this generated code with #if #lf and #ndif, how to generate codes with these conditional inclusions. Thank you for watching. Okay, I hope this video will be helpful to you. Thank you. Bye.